Okay, um, I'm gonna continue where I left off. So we were talking about this last time, and okay, we're gonna move on. If you haven't seen my last video, part 2 and part 1, I recommend you watch that first before watching this, or else it's gonna be very confusing. Anyways, I'm gonna continue. So now I'm gonna talk about the conservation of nucleon number, proton number, and mass energy during a nuclear process equation. So a nucleon number, a proton number, and mass energy will be conserved, and none of them will be lost during a decay. So during a negative beta decay, this is not the parent nucleus because this is just a radiation decay. I just want to give you idea of the nucleon number and the charge. If you remember, at the top one is nucleon, the bottom one is the charge. So okay, so a neutron. Okay, you know what? Let's not focus on the elements. All right, let's not focus on N, P, or E. Okay, just look at the top numbers here. You have 1 in the left side. 1 is the nucleon number. Neutron, I said in the last part, neutron has only 1. Okay, during a negative beta decay, it will produce a proton and electron. Okay, P and E. If you want to know how much nucleon is, proton has 1 nucleon. I already said. Oops, sorry. Here, 1. An electron has 0. So the total sum of 0 and 1 is going to be equals to 1. Therefore, none of the nucleon has been lost during decay, during the transmission. So the total sum of nucleon in here in the right side, it's going to equal to the nucleon in the left side. And this goes the same thing as the bottom. Let's try the bottom charge. Okay, the charge for a neutron is 0 because neutron produces a proton and electron. Proton has a charge of 1, electron has a charge of negative 1. Okay, 1 plus minus 1 is the same thing as 1 minus 1, which is equals to 0. Okay, and that's how you know about the idea of conservation of proton, electron, and the energy. However, the energy will be conserved because during decay, an energy is released. And because the idea of conservation of energy, this energy can be in different types. It can be kinetic from movement or decay. Okay, it could be heat energy, but the total sum of energy is going to be produced during a neutron decay. And actually, supposedly, an anti-neutrino is supposed to be added in here in the equation, but I will be talking about the more details stuff of radiation decay in the other part. So the idea is during a nuclear process, when you're balancing equation, the total sum of the nucleon number and the proton number and the energy in the parent nucleus will be equal to the sum of the nucleon number and the proton number and the energy in the daughter nucleus. And here, of course, I'll give you an example. So this is typical exam question. So we have Rn, the element Rn, okay, and it's going through an alpha particle. Okay, if you sum the other part, I said that the alpha particle has a nucleon 4 and a positive 2 charge. And then if you want to minus this, you must minus the opposite number of the nucleon and then charge number. So helium has a nucleon number 4. so you must minus 4. So 222 minus 4, the PO is going to be 218. Okay, I don't know what PO stands for. Um, I'm not really that good with chemistry, but I think you should know that. So Rn has a charge of 86. 86 minus 2, okay, the opposite number. 86 minus 2 is going to be 84. So PO, the new nucleon, is going to be 218. The bottom charge is going to be 84. And to check easily, you can see here is like that. 2 plus 84 is going to be 86. Okay, the total sum of nucleon on the left side is going to be equals to the nucleon on the right side. Okay, so 4 plus 218 equals to 222. Okay, you can see here. 2 plus 84 is going to be equal to 86. And that's how you know your equation is balanced. Okay, let's say a carbon. It's going to be it's going through a negative beta decay. Okay, um, like I said, if it's only just if it tell you only beta particle, it's most likely it's going to be negative beta particle. Okay, so it's going to produce what do you call it? It's going to produce a negative electron. So the opposite number of negative 1 is going to be plus 1. So it's going to 6 plus 1 is going to be 7. Or to easily just check, 7 minus 1 is equals to 6. Or 0, because the electron has 0 nucleon number. So 0 plus 14 equals to 14. And that's how you know when your equation is really balanced. Okay. Now I can say the left side is the parent nucleus. Nucleus in here, and this is the daughter nucleus here. So in conclusion, you should know how to balance a nuclear process equation using the idea of conservation of nucleon and charge. That's it for this part of the video. I tried to make it short as possible so you can get more idea, but we have more things to talk about in this chapter, so I'll see you in the next part.